So our next video in the data science series is clustering. In this video, we will learn about what is clustering and we will also learn about what is k-mean clustering and how it is used. So first of all, I give you a smaller info of clustering. What is clustering? Clustering is a fundamental data mining technique used to discover hidden patterns and group similar data points together. This presentation will explore the principle and applications of k-means clustering, a widely used unsupervised learning algorithm. Introduction to clustering analysis. So let we have a introduction to what is clustering analysis. So first of all, goal of clustering. Clustering aims to partition data into groups. The groups are known as clusters, where objects within a clusters are more similar to each other than the objects in the other clusters. Unsupervised learning. Clustering is an unsupervised learning method, meaning it does not require any labeled data or prior knowledge about the classes. Clustering is a simple method which do not require any prior knowledge to be done. So let us now understand what is k-means clustering. It is an iterative algorithm. K-means clustering iteratively assigns data points to clusters based on their proximity to cluster centroid based. Each cluster is represented by a centroid, which is the average of all points in the cluster. Basically, k-mean clustering is a clustering method in which there is a centroid of each cluster, which is the average of all the points in the cluster. Setting up the k-means algorithm. Choosing key. Let us understand how we can choose k. The key parameter is k, representing the desired number of clusters. It's essential to choose a suitable value for k. Initialization. Randomly initialize k centroids, which will serve as starting points for clustering process. Let us now visualize the clustering process. First step is assignment step. Assign each data point to the cluster whose centroid is closest. The data points are assigned in such a way to the cluster that the centroid is closest to the data point. Then second step is update step. Recalculate the centroid as the mean of the data point assigned to each cluster. Then third is iteration. Repeat the assignment and update steps until convergence, where the clusters no longer change. Determining the optimal number of clusters. First is elbow method. Plot the within cluster sum of square WCSS for different values of k. Then identify the elbow. Look for an elbow in the plot indicating the point where adding more clusters provides diminishing returns in WCSS reduction. Then optimal k. The number of clusters at the elbow point is often considered optimal for the data. Applying K-means to real-world data. First, customer segmentation. Group customers based on their purchasing behavior to tailor marketing campaign. Then document clustering. Cluster document based on their content similarity for information retrieval. Then third is image clustering. Group images based on visual features for images search and retrieval. Interpreting the cluster results. First, cluster characteristics. Analyze the attributes of data points within each cluster to identify common characteristics and trends. Domain expertise. Apply domain knowledge to interpret the meaning of clusters and draw meaningful insights. Then third is actionable insight. Use the insights derived from clusters analysis to inform decision making and optimize processes. So the conclusion of the video is first, powerful tool. K-means clustering is a versatile and powerful tool for uncovering hidden patterns in data. Second, interpretable insights. Clustering analysis provides valuable insights that can be easily interpreted and understood. Third, actionable outcomes. The insights gained from clustering can be applied to solve real-world problems and improve decision making. So this is the video on clustering. Hope you like it. Thank you.